This is pure past question under equations of a circle. Right? So that's the subtopic in coordinate geometry. So what they're asking us to do here is that they say you should find the equations of the circle. If you haven't watched our videos on the forms of equations of a circle, that is three in some cases. That's the simple one, what I call it a simple form, and then the standard one as well as the general equations of a circle. You may consider watching that video and come back and come and solve this problem. Alright, so the summary to that is that here's the question. So let's first check the question. So let's check the question first and see what they are asking us to find. Now, question number 23. Is that okay? Question number 23 says that write down the equations of a circle which has the points 2, -3 and -1, 4 as the end of its diameter. Is that okay? So this is the question. We are having information. We have that 2 points at the end of the circle. Those are the diameter, and then they are asking us to find the equations of the circle. Of course, so far we know. You see the option. When you get the option, you can see that this one looks like the general equations of a circle. Is that okay? So perfect. Now let's dive into the solution. By the way, the book that I'm using is A Plus series. Mr. Ishmael. So credit to A Plus. Now let's get a question. These are the points that we are having, and we are told that these points are the diameter, right? At the end of its diameter. So if you don't know what diameter is, you have to know that before you can continue. You see, math is a precise language. You need to know that, right? So on this channel, what we do here is that we help you understand the technical terms and the name behind or the image behind the name. Is that okay? So what is a diameter? If you don't know this, you cannot solve this problem. Is that okay? So, but by the way, if it makes sense or it doesn't make sense to you, maybe yours is to just pass and move on to the next level of your education, right? And leave everything to the advanced mathematician, whereby they can apply the theory in our daily life. Is that okay? So let's continue. Now they say the points, these 2 points here are the end of its diameter, right? So consider this a circle. Of course, you have been asked to find the equations of a circle, right? So you have three different forms of equation. But when you look at the option or questions like this, you are required to write the general equations of a circle. So these are the end of the diameter. What diameter means is that when I draw a line from the end of a circle that passes through the center to the other end of the circle is what we call a diameter, right? If it doesn't pass through the center, then it's not a diameter, right? Just like your name, you have been identify maybe your image. We use your image to identify your name. So if that image is not appropriate, we cannot call it by your name. So the same applies to anything in mathematics. Is that okay? It's a diameter, so that's one thing you need to pay attention here. Diameter is a line that passes through the end of one circle, and it passes through the center to the other end of the circle. Is what we call a diameter. Is that okay? So these 2 points are the end of the diameter. So these are the 2 points being given to us. They are the end of the diameter. Now we know that the general equations of a circle, if you haven't watched, you may consider watching that video. Is that okay? So the reason why we brought another point here is that for us to be able to write down perfectly the general equations of a circle. So what do you have to use if you have this type of problem, right? You are given only 2 points and then they are asking you to find the equations of a circle. Is that okay? What you do is that, you see, when I extend this line to the circumference, what I mean by the circumference, that is the circle over here, right? That is the circle to the other end is there's a property that says that here they form what? A 90 degrees. Is that okay? That is a law. You just need to obey that law. Is that okay? When I move from the end of one diameter, that is the circle, to the other end here, at the joint of those two lines, it forms a 90 degrees. Is that okay? This is a law. This is a property. There's nothing you can do about the law. It's a policy. So you need to obey that. Now, if these two lines forms here and then they form what a 90 degrees over here, what happened? What happened? So the rule here says that the gradient, right? The slope. You know the meaning of a slope, right? Way back. That is the okay. I will explain that in a few minutes. The slope. When I multiply the product of the two lines, right? When I multiply the slope of this one and the slope of this, that one has to give me a -1, right? So here, when I multiply m1 by what? The m2, it must give me a -1. That's why it's also another law. You must obey that. Is that okay? So I'm calling the gradient of the first one to be m1 and the gradient of the second one to be m2. If you don't know what gradient it is, you may consider searching that before you proceed. Is that okay? By the way, so I define the gradient here. This is how it's being defined. So the gradient is what? Y2 minus y1 over x2 minus s1. Once again, for you to be able to use this type of definition here, you should know where the y2 is coming from, where y1 is coming from, where s2 is coming. This is how you use any formula in mathematics. You should know where the players are coming from. This is what I call them what? The players. Is that okay? We know the properties that when I multiply the gradient of the first line by the second one, it must give me a -1. So this is what I mean from the diagram. So the gradient, the slope of this line, right? The slope of this line, when I multiply that by the slope of this one, it must give me -1. But remember, it is not always. This one is applicable when they form a 90 degrees over here. Have you seen? It is a law, so you need to obey that law. Okay, now let's proceed. Now, so when you use this formula here to find the gradient, you can see that, so the gradient of m1, so I'm calling the first line m1, right? m1. So the gradient here is that, I know the definitions of the gradients is who do you call a gradient? So you call that person a gradient when you have a y2 minus y1 divided by x2 minus s1. Is that okay? So where can you get a y2? Where can you get a y1? And so on and so forth. So let's consider this line. Obviously, the end points are what we call the y1, y2, s1, s2. Is that okay? Of course, every point is in the form of sy, right? In this geometry word over here, we cannot locate it by just a single number. We normally locate it by 2 in pairs, right? So this point here is at sy, right? We don't know that. So here is specifically it's at what? 2 -3. So when I consider this line here, so I'm calling this line what? M1. Can you see that? I'm calling this line M1. So when I consider this line here, this one can be my Y2, and then the next Y here can be what? My Y1. Have you seen the red pen over here? So Y2 and the Y1, or you may interchange it. Nobody cares about that. Or the most important is that you should know how to arrange. So I'm going for this one to be my Y2, and then this one will be my Y1, and this one will be my X1, and then this one will be my this one will be my X2, and then this one will be my what? X1. So perfect. So the gradient of the first one is what? Y, as you can see from this part here. I will see that. So this will be my y2. So I'm just replacing. So y2, which is the y here, minus, according to the definitions of the gradient, minus y1. So what am I calling the y1? So it's what? -3. Is that okay? So minus -3. Don't be confused about this negative. There's already a negative sign here, and my y1 here on each one is what? -3. Okay, don't be confused with this one and the negative in the definitions of the gradient. So that's why I'm having the minus and the -3 over here. So divided by x s2, which is the x going to be what? X here. In this case, can you see that? This will be my x2. So and then this will be what? My x1. So x minus 2, right? So when you do a calculation perfectly, you can see that y plus 3 over what? S minus 2. The same applies to the gradient of the second line. So I'm calling the second line M2. So you can see. So here is the gradient of what? The second line, right? So the same thing. This will be my y2. This will be my y1. The one in the red pen, and then this will be my s2, and then this will be my x1. So when I plug that into what? The definition of the gradient, I'm having something like this, right? So y minus what? 4 over what? X minus what? -1. Pay attention to that. So when you do a calculation perfect, you have what? Y minus 4 over x plus 1. Now remember, we know that the product of these two lines, so what I mean by the product is that when you multiply the gradient of the first one multiply by the gradient of what? The second one, that has to give me a what? A -1. It is a law, right? When is this law applicable? It's only applicable when the two lines here from the end of the diameter form a 90 degrees over here. Of course. Is that okay? If they don't form a 90 degrees, then there's no need for you to apply this method. And the rule says that when I extend this line from here to the circumference and then move from the other end here, sure, they form a 90 degrees over here. Is that okay? Once they form a 90 degrees over here, you can apply this. Right? This is just a law, right? But you must know when to use it. Just like a cutlass. When do you use a cutlass, right? Something like that. You must know where to use. When you use it wrongly, you get it wrongly. So you have to use that correctly. Okay. Now let's move on. Now you find the gradient of this one. You find the gradient. So let's go and check whether when you multiply the two, that one has to give us a negative one. Is that okay? So let's move on. Then let's go and multiply. So this will be what our m1, and then this will be what our m2, right? So when I multiply the m1, so this is the m1. When I multiply that by m2, we know by definition that that one has to give me a negative one. Is that okay? So perfect. When you proceed, I don't know how best we can multiply this. So I choose to what? You may consider multiply that by any method. Someone may decide to go straight for the y, multiply by this one, give us a y square, and so on and so forth. So I choose the y, multiply by everything here, right? I see that this y I multiply by everything here. The top one multiply by the top one, the down one multiply by the down one. Is that okay? So this y I multiply by this everything here, and then the 3 positive 3 also multiply by everything over there. So this is what I'm having here. So y into bracket y minus 4 all bracket plus what? The 3 here. So it's going to multiply everything as well. So I'm having what? Y minus what? 4. The same applies to the down one, right? The same process applies to the down one. So pay close attention here. So don't be in a hurry, right? Step by step. No one is chasing you. So take your time and do your calculation very well. Easy and step by step. And then let's move on. When you do a calculation correctly, you arrive at something like y squared minus 4y plus 3y minus 12. You may consider pausing the video and try this, right? This is how you solve mathematics, and come back and check the solution. Alright. By the way, if you enjoyed the video so far, you may consider joining our YouTube channel and then our WhatsApp group where we interact with the student one-on-one for them to have an easy access to mathematics past question. Alright, so when you do a calculation perfectly, then you can see that you get to the point where you are having what? Here you do a cross multiply, right? Cross multiply. So this guy going to multiply the negative 1 here. So I'm having y squared minus, so y minus 12 is equal to what? Negative 1 multiplied by everything here, right? When I expand the brackets, you can see that negative 1 times this will give me what? Negative x squared. Negative 1 times this will give me a positive what? X. Negative 1 times this, because negative will give us what? A positive over here. Now let's rearrange everything. So we are bringing everything to what? The right hand side of the equation. Is that okay? But why are you doing all this? We know that this type of equation looks like a general equations of a circle. And if you don't know how the general equations of a circle are, you may consider watching that video. Okay, so when you rearrange everything, it means that we are bringing everything to the right hand side of the equation. Is that okay? So what you do is that this is how the general equation x squared comes first, right? So x squared and then plus y squared minus what? X minus y minus 12 minus 2, because we are sending everything to the right hand side of the equation. So when I group everything perfectly, I'll have what? S squared plus y squared minus s minus y minus 14 is equal to 0. This is exactly how the general equations of a circle looks like. Is that okay? So this is how you solve this type of equation. When you are given a 2 point that's at the end of what? The diameters of a circle, you have to use this method, right? To write the general equations of a circle. First of all, you need to identify the gradient of what? The circle, right? The gradient of it by using the gradient formula definition over here. And then use the second one is what? To use this one. You know that the product of the two gradients is what has to give us a negative one. So you multiply the two gradients, you equate it to a negative one, and then do a calculation. Very, very simple. So if you've enjoyed this video so far, don't forget to share, like, and comment our section below. So if you have any problem, we can easily attend to you for you to have an easy access to math questions and pass and pass in your final exams. Thank you for watching.